Hi everyone, for today's lesson we are going to continue with Unit 2, Day 1, but this time we're going to discuss end behavior. Now recall, end behavior of any function, whether it's a polynomial function or not, is all about what's happening as x approaches positive infinity or as x approaches negative infinity. That is what end behavior is. The end behavior of a function's graph is the behavior of the graph as x approaches positive infinity and as x approaches negative infinity. For polynomial functions, the end behavior is determined by the function's degree and the sign of its leading coefficient. So it's really important that you're able to identify a function's degree, which remember that degree is the largest exponent of that polynomial function, and the leading coefficient, which is the number that is in front of the variable with the highest degree. So the first type that we have is an odd degreed function. And we know this is an odd degreed function because of the fact that our end behavior, the arrows of our end behavior is going in opposite directions. For these types of problems, what I want you to think about is I want you to think about linear functions. Think about a linear function. In this problem, this is an odd degree because our arrows are going in opposite directions, and our leading coefficient is positive. It's a positive number. So if you think about what a positive linear function looks like, it's going to have slope where our arrows are going in different directions. So if you can think about that for odd degrees, whether that degree is to the 5th power, to the 3rd power, to the 7th power, and our leading coefficient is positive, it's always going to have the same end behavior as a positive linear function. And as x approaches positive infinity, that's looking to the right of the graph, what you're going to notice is that we have ourselves an arrow that is pointing up. And so therefore, as x approaches positive infinity, what's happening with y is that, or our function is that it's approaching positive infinity. And as x approaches negative infinity, our function has an arrow that's pointing down, and it's going to be approaching negative infinity. So as x approaches negative infinity, f of x approaches negative infinity. And it has the same end behavior, once again, as a positive linear function. If you think about linears, like if we were to look at y equals 2x plus 5, we have a degree of 1, which is odd, and a positive leading coefficient. Let's go ahead and look at this other one. This is also an odd degree. But this time, our leading coefficient is going to be negative. And if you think about it being like if you think about a negative linear function, those are those functions that have negative slope. Like y is equal to negative 3x plus 2. Our degree is odd, our leading coefficient is negative, and it's going from up to down. So as x approaches positive infinity, we have ourselves an arrow pointing down, which means that it's approaching negative infinity. And as x approaches negative infinity, we have an arrow pointing up. And therefore, our function would approach positive infinity. So when it comes to odd end behavior, the end behaviors are going to be opposite. So it's either going to be positive matches with negative or negative matches with positive. If the degree is odd and you have a negative leading coefficient. If you have a positive leading coefficient, you'll have positive positive and negative negative. So the whole point is that your end behaviors are always going to be different end behaviors. One will be positive and the other will be negative. One will be positive and the other will be negative. They have opposite end behaviors. This is different than an even function, which most of the functions that we have studied so far in this class have been even functions. We've studied absolute value functions, and we just finished discussing quadratic functions. And so whenever you see that your arrows are pointing in the same exact direction, this means that it's an even degreed function. In this case, because our arrows are both pointing up, it's an even positive function. Our leading coefficient is positive. And as x approaches positive infinity, we have ourselves an arrow pointing up. It's going up to positive infinity. And as x approaches negative infinity, we also have an arrow pointing up. So that means that our function is approaching positive infinity. And whenever you are asked to identify the end behavior of an even positive function, I want you guys to think of a quadratic, of a positive quadratic. So in a positive quadratic, it's very easy to draw those. We have up as our end behavior. And so if you can think about it like that, so like in this problem, we would have y is equal to like 2x squared minus 3. Our degree is even, and we have a positive leading coefficient. The other type that we have is an even function, but the leading coefficient is negative. And once again, our end behavior is going to be the same, but because our leading coefficient is negative, that means that our end behavior is going to be down, down. That means as x approaches positive infinity, we have an arrow pointing down, which means that the graph is approaching negative infinity. And as x approaches negative infinity, we also have an arrow pointing down. So it's approaching negative infinity. So in terms of our end behavior, f of x is always going to approach the same exact infinity. So it's going to go in the same exact direction. So if we have an even positive, we have up, and an even negative, we have down, down. And whenever you are asked to visualize an even negative, I always want you to think of a negative quadratic. A negative quadratic would be where we have our arrows pointing down, and this would be something like y is equal to negative 4x squared plus 5. Our degree is even, and our leading coefficient is negative. So if you can imagine what that would look like, draw a quick sketch and then put in all of your infinity symbols to write out your end behavior. All right, let's go ahead and flip the page and practice without graphing. Describe what the end behavior of the graph is by completing these statements. So looking at our first example, we have f of x is equal to negative 2x cubed plus 2x squared minus 3x to the 4th power plus 5. So the first thing we want to do is SF means standard form. Rewrite it in standard form if necessary. Standard form means that your degrees are going in descending order. And what I see is 3, 2, 4, 0 as my degrees. And so this is not in standard form. You have to put it in standard form because what a lot of times kids will make the mistake and say, oh, this is an odd function with a negative leading coefficient. But in reality, our leading coefficient is actually negative 3x to the 4th power, and then a minus 2x cubed plus 2x squared, and then plus 5. Standard form means that your exponents are in descending order, going from largest all the way down to smallest. So in this problem, our degree is actually an even number. Our degree is 4. And our leading coefficient is negative 3. Negative 3 is a negative number. So this is an even negative. And if you think about what an even negative looks like, think about a quadratic where our arrows are pointing down and then down again. So as x approaches positive infinity, that's looking to the right of the graph, we have an arrow that is pointing down. So this function is called f of x. So I'm going to call it f of x approaches negative infinity. And as x approaches negative infinity, that's looking at the left side of the graph, we also have an arrow pointing down. So we would say that f of x approaches negative infinity. The next two problems are a pair and a solo. I strongly recommend that you pause the video and try these problems on your own, and then we will discuss them once I see you in class next time. Our last example for today is example number 5. It says, describe the degree and leading coefficient of the polynomial function whose graph is shown. So looking at letter A, we have an arrow that is pointing down and then an arrow that is pointing up. Because we're going from down to up, looking at the graph from left to right, it looks like it's increasing as our values of x increases. So therefore, because our arrows are going in different directions, I know that the degree is an odd degree. And because overall, going from left to right, it is increasing, just like a graph with a positive slope, like a linear function with a positive slope. So that tells me that my leading coefficient is positive. Next, looking at letter B, I have two arrows that are pointing in the same direction. And because they are pointing in the same direction, this is an even function. And because both of these arrows are pointing down, this graph behaves just like a quadratic with a negative leading coefficient, with a negative a value. So therefore, I'm going to say that this has to be an even negative function, an even degree with a negative leading coefficient. And finally, I have arrows pointing in different directions, which tells me that this is an odd function. And the arrows are going from up to down. Reading the graph from left to right, overall this graph is decreasing. And so therefore, I know that my leading coefficient has to be negative. And that is the end of today's lesson discussing end behavior. If you have any questions over anything that I just talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.